Recalc. So this time we're actually going to create a model and make a prediction. So this is one of the really cool things that mathematicians do. You could see them in physics making physicists do actually make models as well. My father's a physicist. He does make models and predictions with physics. So yeah, physicists also make models. Mathematicians make models, and so that's what I'm going to show you, how to make a really basic model and make a prediction from it, which is very cool. So y equals e to the bt. We're going to do an exponential model, and so what you're going to do is the step one is always to find a, and a is what we would call the initial condition. It's like if time is zero, what is the output? It's that kind of concept. That's going to end up being A. That specific Y is going to end up being A. So you can see here that Carl buys an antique car for $50,000. So when he gets the car, that's the initial condition, because that's when the experiment, so to speak, starts, or the experience starts. Now this will always end up being A. So in general, you can just, once you figure out the initial condition, you can just put it into the model. You don't need to do any calculations or show me any work, but I just want to show you so you understand that when t is 0, that this specific y is actually also a. I just want to explain that to you. So if I take the model, I just show it to you once and I won't overkill it. So in this case, you have 50,000 equals to a, b. bt is 0. Okay, so 0 times b is 0. I just want to show you how it calculates out to eventually be a. All right, now e to the 0 is 1. And therefore you can see that a has to be equal to 50,000. Okay, so I'm verifying that this is always going to be true. This will always work out. All right, so that's your first step. You want to find A. In a standard model, the second step then would be to find B. Now you have to be given a complete data set, a second complete data set to find B, meaning you have to be given another T and Y, another complete set. It can't be missing like half the information. So that's the second thing. In 7 years, the car will be worth $72,000. Okay, so in 7 years, the car is going to be worth $72,000. This is a complete data point. So I'm going to take what I've already learned about my model. Okay, don't ever throw A away. Don't ever change A. A is a fixed value once you find it. You just carry it along for the rest of any application of this problem. All right, so now what I'm going to do is I'm going to find B by plugging in this T and this Y. So here we go. So as you know, the first step is always to isolate the exponential model once you start solving. Just because this is so convenient to do, let's just cross out the zeros. I know we could do more than that, but that little step's so easy. All right, now we'll take the ln of both sides. Yeah, you can reduce that all the way if you want. You'll get the same answer. All right, we're bringing the exponent down. That's the step I'm on. As we know, ln of e equals 1. Okay, then we divide off the 7. We're almost there with the b value. And again, as I've said a zillion times, you've got to really watch the brackets in your calculator. All right, looking for 5 to 6 decimals on this. I will remind you on the exam and the final that's what I'm looking for. Okay, so 72 divided by 50, close those parentheses. Okay, good. Divided by 7. All right, lots of decimals on this, please. 0.052092 052092. Okay, gang, notice it's positive because antique cars go up in value, okay? So they should be increasing with value with time. So that's why this guy's positive. And let me see if I can just stay on this page. All right, so now 3E 0.052092T. Okay, this, once you have the A and the B filled in, we consider this to be a complete model. Meaning this, if I'm hired to build a model for this antique car owner, I've now built the model and he can ask me, okay, I want to know in 10 years how much my car is worth. And I can go, okay, I will now tell you how much your car will be worth in 10 years, right? Because this model now you can calculate the value of his car depending on time. Or if he wants to know, like, when is my car going to be worth $80,000, then you can tell him how many years out that'll happen, right? So if you know Y or T, you can answer the other. All right, but he wants to know when T is 10, what's the value of his car. So let's go ahead and tell him. Let's figure it out and tell him what the value of his car is going to be. You know, since this is a 10, I always just find this so easy just to move the decimal over one time. You don't have to do it the way I'm doing it, but since it's 10, I just multiplied that because that's just beyond, it's almost like insulting to my brain if I don't do that. All right, so now I'm going to plug it in, but you do it your way. It's always important that you have your own way that you prefer. Okay, times, all right, so I'm plugging in and I got 50,000 times Shift E 0.520 multitasking. Okay, 50,000 times E. Okay, let me see if my finger can do it correctly this time. 0.52092. I'm gonna get you in the habit of closing those parentheses. Ooh, nice. 84,000 bucks. 178.79. Ooh, that's a nice chunk of change. Okay, so 10 years out from his investment of $50,000, the car is going to be worth 84,000 plus. Okay, gang, I hope you enjoyed this one. I'm definitely going to ask you this particular, I'm going to change the numbers, but in terms of like asking you to create a model and make a prediction, this is the most important question from 3-5. It will be on test 2 and it will be on your final. Okay, this one's the most important of making that model and making the prediction. All right, that's the end of this video. I'm going to pick up with another example in a moment. Catch you. Bye-bye.